I'm Terrio from George Washington University, and this is Fighting Fake News and Encrypted Messaging with the Fuzzy Anonymous Complaint Tally System, or FACS. Fighting Fake News and Encrypted Messaging with FACS. So, we all know about fake news, created by low credibility sources, and research shows that spread mostly by unwitting humans and not bots, and we see it everywhere. Facebook, Twitter, all these social platforms, messaging, people send it to you, and obviously this is not something that we want going around if we can. Not great for society, just something we want to try to get rid of. So, how do social platforms do it? Well, they have a few major ways that we've seen come out recently. One is by algorithms, so things like keyword identification, blacklists, machine learning, and we've also seen that they've crowdsourced it, so they've had users just go ahead and mark things as fake news. And research shows that this works pretty well, and that a group of average users can match the accuracy of professional fact checkers. And so, okay, well, that's great and all for those big social platforms, but there's one big thing about those. These tools rely on content being in the clear. So when it comes to end-to-end encrypted messaging systems, things get a little bit more difficult, even though fake news is also spread on these platforms. So we see things such as Signal, WhatsApp, and Telegram having fake news spread across them, but they don't have access to content. So how can these platforms deal with fake news and moderate it? Well, we've seen some tools come out, such as forward limiting, message ranking, searchable encryption, which is akin to blacklists, private set intersection, which is similar to the keywords in private machine learning. But a lot of these tools can't really cover the nuance of what fake news is and actually moderating it. So for example, keywords, right? We see the first few words, those are very common fake news. Usually not much else. But the next three words, well, those words are common in fake news a lot, but they're also common in real news and everyday conversation. So if we use that tool to try to moderate fake news specifically in these systems, well, it may not actually be that accurate. And so really what we see is these tools don't really cover that nuance of fake news. So how do we solve this? Well, let's first define fake news a little bit more strictly. We're going to call fake news content that is seen by many users or viral, but many users can discern as false, going along with the research we've seen that a large group of average users can discern it as false. Okay, so what are our goals then for actually moderating this? Well, again, like the research shows, what we really want to do is just crowdsource the detection of fake news. We want that average group of users to just go ahead and tell us what fake news is instead of trying to prescribe it to them, right? And so we want them to crowdsource the detection, ideally identify the sources of viral fake news, since it's just a bunch of low credibility sources that there's not a lot of, and obviously since it's end-to-end encrypted platforms, we want to continue to maintain that privacy and security that they provide. Some non-goals are setting in stone what specific content should be moderated. So beyond saying moderating fake news, we don't really want to say, okay, this specific thing is fake news or that specific thing is fake news. Beyond that definition we gave, we're trying really not to get into what is and isn't fake news. And we're just going to let the users to actually decide that. And we're trying not to actually use the system to decide the fate of accounts and content. We're not really trying to say what should happen when it's revealed who originated fake news and what the actual fake news is. That's, again, up to the platforms and up to other people to decide what should happen and the best way to actually deal with that. So really, all we want to do is rely on a lot of users complaining about a message to identify fake news. Okay, so there's a current approach to this, and how this works is that message, right, when it's created, creates a path as it's forwarded from user to user, and this path is encrypted. And on a message complaint, right, this path is revealed. And so that's great because now we have a way to track these forwarded messages and actually detect and moderate them. But there's a caveat here. One user can reveal the whole path. So that means that any content, not necessarily just viral fake news, can easily be revealed by a single user. So if you have some sort of chain of custody of a document and someone along that chain of custody decides to report it for whatever reason, well, now that whole chain of custody is revealed, and so is the document by a single user, right? And that, obviously, that document isn't viral fake news, it's just a random document. So we want to try to avoid that. We want to make sure it's only that viral content, only fake news, that actually can be reported and can be moderated. So this brings us to our solution. So first we're going to make a few assumptions. First, that the messaging system is a centralized end-to-end encrypted platform like we've talked about. We're also going to assume that all messages are either original or forwarded. And finally, we're going to assume that complaints are rare relative to the number of messages sent. So users aren't just complaining about literally every single thing they see. And the actors in this setting are going to be the server, who we're going to assume is semi-honest, because if they're malicious, well, they can do a lot worse things, arguably, than just spread fake news. We're going to assume that most users are semi-honest and are going to report fake news when they see it. And we're going to assume that some users, obviously then, are malicious and they're spreading fake news or helping in some way. So that brings us to our system, fuzzy anonymous complaint tally system, which we'll get into the details here. But first, let's go over some advantages of the system. First of all, the users can still send and forward messages, like always, very important. They can complain about messages, and they can start audits when complaints have reached a threshold, meaning that when a user sees that some sort of message has been reported a bunch of times, right, they can say, hey, server, this is like beyond the threshold of what an average group of users complaining is. You should probably moderate this. And so the server itself, obviously, is going to transmit the messaging, hence the centralized platform. It's going to moderate reported content or the originator of that content, and then it's going to store complaint information obliviously. That's very important to maintain that privacy and security. And then finally, it's going to actually recover that originator upon an audit. So as far as security goes, users should not be able to complain about a message they haven't received, obviously, manipulate number of complaints for a message by a significant amount, or falsify the message originator. As far as privacy goes, we want to maintain like what we had and continue to maintain that privacy and security, so users and servers should not be able to see what users are complaining about, complain about a message they haven't received, or any of that. So that brings us to our solution, the collaborative counting Bloom filter, which is an oblivious multi-counter data structure. So really, it's a Bloom filter, a counting data structure that is oblivious, and it maintains some sort of tally. So really, what happens then is that we just have all of these multiple counters, and whenever you try to increase one of those counters, that's going to be oblivious to whoever is maintaining that data structure. And in this case, the person increasing the counter is going to be users reporting messages, and the server itself is going to be the one maintaining that data structure that shouldn't find out what you're actually increasing and you're trying to increase the count of. And obviously, then, this achieves previously mentioned goals. And so we see what happens is if a bunch of users report a message, well, what's going to happen is that originator is going to get revealed after a certain threshold is reached, and that originator himself or theirself is going to get moderated. As far as storing complaints goes, we had this first attempt where the server maintains a table of counts, similar to a count-min sketch. Each message is going to be assigned to a set of slots, and the slots will only be known to the users. So that way, when they go and complain, all they do is they go and increment all slots of the message, and as far as counting goes, they just take the minimum to find the current number of complaints. But we see there's a problem here. Complaining patterns are revealed. So if two users go and report on the same message, they're going to be incrementing all the same set of slots. And so that way, even though the server might not know exactly what they're complaining about, they still know they're complaining about the same message and that they've received the same message. And that's something we want to try to keep private from the server. So how do we do that? Well, now we will just go ahead and actually make all these slots, instead of just being counters, they're all going to be zeros or ones. And that means that the threshold instead is going to be derived from the sum of slots per message, so the sum of all those bits per message. And as far as complaining goes, a user will just simply flip a bit from 0 to 1, And what that gets us is now there's no overlap between the slots that the users complain to. So if two users complain about the same message, well, that's fine because the server won't know because they're complaining to two different slots. They're incrementing two different slots, and the user or the server doesn't know that those two slots correlate to the same message. Well, how does the user actually know what slot to increment? Well, as far as message or origination goes, that's how we solve it. So when a user actually goes to originate a message, they'll send the secure hash of the message to the server. The server will take that and their identity and sign it, and then send it back to them, and that user will include it in the message whenever they forward it or send it to someone. Meaning that when you receive a message, you can just go and check and say, hey, well, the originator, right, that is still linked to this message that I received, and it's the same message that is equal to the hash, and it's signed by the server, so I know that the server knows, too, that these two this originator and this message are linked. And so that way you actually know that what you just got and the originator is still valid. Well, okay, there's another problem besides deciding what slots go along with what message, and that is if a malicious user has received a message, they can simply set all bits to 1, which really defeats the whole purpose of this, because now a single user can go ahead and reveal all those messages that they receive without that threshold being reached. And obviously we don't want that because that's the whole point, is that we're requiring some threshold of users. So how do we fix that? Well, this brings us to the final attempt in the actual version of facts and the counting and collaborative flume filter that we have, which is that users, just like the messages, are assigned their own subset of the slots that they can report to. So instead of being able to flip any bit, now they'll end up being only able to flip around 1 bit per message on average. So what that means is that they can only complain once on a message. So now we're back to being able to have that, well, we need to reach a threshold before something actually is moderated, which is great. And so, okay, what does that look like in practice? Well, say the dog reports a message, then the cat reports a different message, and then again receive that message that the dog receives and reports it. And as the cat reports it, they go and look and say, hey, I'm looking at all these bits, and they're all set to 1, which means that most likely this message has reached the threshold, and it goes and tells the server, hey, you should moderate this. This has reached the threshold of complaints. And it reveals the actual message, and then that hash, and then the originator, the encrypted originator ID to the server, and the server can go ahead and moderate that content how it chooses. So now we've seen how it works, but obviously this is not the count min sketch anymore, so we can't just take the minimum of all the slots to find the count of the reports. So how do we actually go ahead and do that? Well, what we do is we go and approximate the true number of complaints from the number of bits set, instead of just summing them all together. And so that solves the issue of, well, some messages may have overlapping complaint slots, which may influence the count. So in practice, in actual experimentation, what we see is that even with a large number of background complaints, meaning a large number of complaints on other messages, that for a single message, the actual threshold that is reported as triggering an audit is very close to the explicit threshold that we set. And this is great because that means that facts achieves good accuracy for a wide variety of thresholds and background noises when we're doing this approximation. Finally, obviously, there are a few issues we see with this system, such that malicious users could share messages with each other, meaning they could just send their messages to all of their friends and then they all report it all at once, even if it's not fake news. The server can see that a user has complained about something, and so even though the server might not know what the user is complaining about or why, the server still sees that the user has complained about something, and some people might prefer to keep that private. And finally, this facts system, only identifies the originator, not users spreading it widely, meaning if a low credibility source just forwards it to a single bot and that spreads it around, we won't be identifying that bot that's a heavy spreader of the fake news. And also, there are some performance issues, such as the need to sync the collaborative counting bloom filter between the server and all the users making those reports. So if all those users are trying to report on similar messages, well, the server now has to sync that collaborative counting bloom filter that's shared between all those users and somehow manage that, which can create bottlenecks. Thank you for listening.